చెట్టులతో బాబమ్మ
Okay, behavioral modeling. So continued. So in the last class, we have seen that the memory elements which are associated with synchronous reset signals or maybe synchronous reset signals, so that normally we encountered in digital electronic circuits. Okay. Now we are going to see one of the example of complex design, that is an 8-bit resistor. Okay, so we talk about 8-bit resistor. Okay, so we want to describe an 8-bit resistor with the help of Verilog HDL. For that one, we need a block diagram. So how 8-bit resistor will work? Okay, something like this, black box. So it has got a input signal, for example, DAN signal. It will produce D output signal, but of size is 8-bit size. So it is produced in 8-bit size. So it is associated with a clock signal, CLK, and it is associated with reset signal, RST. Okay. Now we want to write a Verilog program for this resistor. So do you have any idea how to write this one? Okay. How do you write a Verilog program for this one? So it is just look like a D flip-flop, right? But the size is 8-bit. As simple as that. Okay. So what it has to do? So in general, we are using the reset signal is the topest priority. That means asynchronous reset we normally use, and the clock signal, and the DAN signal, and D out signal. Okay. So when the reset signal is equal to 0, okay, better I will write when the reset signal is equal to 1, irrespective of the clock signal, irrespective of DAN signal, the output is equal to 0. But we should say that what size of the 8 bits, what is the size of this one? It's an 8-bit of 0. Or instead of 8-bit of 0, I will write it in this way. 8D0. Okay. If the reset is not there, for example, reset is 0, if we have a clock signal is equal to high, then whatever the DAN signal is there, the DAN signal will go as an output signal. Okay. So we find the DAN is assigned to D out. If reset is equal to 0, for all other cases, for others, okay, irrespective of the DAN signal, the output is previous value only, right? So this is what the truth table that we can write. So set D out. Are you able to write the program? It is a simple one. Okay. So better I will consider. I will take it from other lecture. It is slow. My voice is spontaneous or it is delayed. Can anybody help me? My voice is clear or it is delayed?
It says clear.
Clear now? Okay. Okay, so D flip flop, right? I will consider this. Okay. Copy. And then I will go here. Okay. So what is the change that I should write here? So instead of D flip flop, it is a resistor. Reg underscore 8-bit. That is how I have written. Okay. But reset and clock is 1-bit size only. Huh? So, but D out is DA and D out are different size. Therefore, I'll write input 7 down to 0 of DAN signal. Okay. The output is also an 8-bit size. Okay. So I'm going to change this one is from 7 down to 0 of D out. Okay. Therefore, positive so remaining is same. Whenever we find the positive edge of the reset signal, but yeah, we have to change here. It will be 8D0. Otherwise, 8-bit of DN will be assigned to 8-bit of D out. Okay, as simple as that. Only thing is that we have to change the input signal is something like this. I hope you have understood this point. Okay, so this is called 8-bit resistor. So, but if you want to write 8-bit resistor, something like this also. Okay, this is the one way of writing the 8-bit resistor. We can use the structural molding for the 8-bit also. So let us write like that. So let us do that one also. 8-bit resistor using structural modeling. So what do you mean by the structural modeling? That means we should know the so why it is saying like this. Using structural modeling. So let us write a block diagram. As all of you know that the block diagram already mentioned. It requires data input signal, DN signal. This is equal to D out signal. For the simplicity, I'm going to write in this way. For simplicity, I'm going to write instead of this one, I'll write D is my input, Q is my output. Okay, of size is 8-bit size. This is also 8-bit size. This is the clock signal. This is the reset signal. Okay. Now, what is the internal to this circuit? That's important. So what is the internal to this circuit? So the internal to the circuit is something like this. It's a parallel in parallel out resistor. Generally it is a parallel in parallel out resistor, not a shift resistor. Okay. So we have to consider 8 resistors here. 1, 2, 3, 4, 5, 6, 7, 8. 8 resistors. Okay. So all these resistors are synchronization clock. Okay. And of course there is a reset signal also. Okay. So I hope you can understand this point. All these are edge triggered flip-flops. So I'm going to use the D flip-flop for to realize the resistor, right? So I'm going to consider all these things. This is the clock of this one. Sorry. Why it is becoming very slow? I don't know. My system is performance is reduced. So this is the clock signal. Similarly, there is a reset signal as well. Okay, for the simplicity, I'm going to write another color. This is reset signal. We'll go and sit here. We'll go and connect here. So all the flip-flop having the same resistor, same reset signal. Okay. Now the output is, I'm using another color. This is my output. This is called, for example, Q7. Okay. This is called Q6, Q5, Q6, sorry, Q4, Q3, Q2, Q1, Q0, right? Similarly, what is the input here now? The input is D7, D6, D5, D4, D3, D2, D1, D0. So that is what actually inside of your module. Okay. So this is what actually that is available inside of your black box. This is the clock signal. So now this is what the circuit diagram that we have, and we need to develop the 8-bit resistor. So we need to write a Deadlock program for this one. Okay, so let us write a Deadlock program for this. So if you want to write the Deadlock program for this, we need to write a, first of all, D flip-flop separately. Okay, already I have written the D flip-flop here. So I have written the D flip-flop here. Okay, this is actually 8-bit resistor, right? So I need to take the 8-bit resistor from previous class. Okay, so let us start the module. Okay, so this is actually a 8-bit resistor. Okay, try kodada. You should not write like that. Class 8-bit resistor underscore structural struct. So we have a DN signal. Sorry, what is the signal that we are using? RST, clock, D, and Q. Then, so దీంట్లో మనకి inputs ఏంటి? Inputs are RST, clock. What is the another input? Another input is 7 down to 0 of D. So what is the output? Output 7 down to 0 of Q. Do we need to write the register Q here now whenever you are writing the structural modeling? So the answer is no. We need not write the Q as a register data type when we are writing the structural modeling. Okay. Now, so we have a D flip-flop now. So we have to take a D flip-flop. We need to define a D flip-flop now. So D flip-flop is something like this. It is something as a DAN. We have a D out. Okay, we have a clock signal. We have a reset signal. Okay, we need to write a Deadlock program for this one. Already we have written in the previous class. We have written what is the name that I have given. What is the name that I have given? So here D flip-flop asynchronous. I'm writing. Okay. So this is the program. Again, for your sake, I'm going to copy this one. Copy and then paste somewhere else. Okay, and go to this one. I want to copy this one. Okay, I should copy here. I should paste here. Okay. Okay, so D out here. Okay, fine. So I have to call this flip-flop, right? So how many times I need to call this flip-flop? How many times? How many flip-flops are there here? 8 flip-flops are there. So let us write the numeric nature for this one. This is, for example, D0, D0 rather, or a D flip-flop, or I can say that M7, M6, M5, M4, M3, M2, M1, M0. Okay. Now I need to call this one. First, I want to write from starting from LSP. Let us write. So how do you write this one? Can you help me? Can you please help me? So it is calling from this name. Okay. D flip flop underscore. Okay, not like this. D underscore flip flop underscore ASY. What is the name of this one I have given? M0. What are the variables I'm using? Reset signal, clock. The same names I'm using for this one also. There is no problem. But instead of DAN, what is the thing that I have to consider? D naught I need to consider, and Q naught. So therefore that is called D naught. Sorry, I should not write like that. D of 0, Q of 0, because since we are writing for vector notation, right? That's how. So how many times I need to use this one? So I have to use this one for 8 times that I have to write. Okay. Paste. Copy. Paste. Two.
Sir, we can use array concept no, sir. In one line, it will be completed.
Yeah, it is possible to use, but reset and clock signals are different size, no?
Okay. Yes.
So, yeah, we should not use. Five. Sixth one. Seventh one. Eighth one. Okay, that's it. So finally, we need to write the module with the change of all these things. Let me check after some time. So I will write end module. So don't forget to change these values. Okay, this is the one. So this is the one module number 1, 2, 3, 4, 5, 6, and 7. Similarly, this is 1. This is also 1. This is 2. This is 2. This is 3, 3, 4, 4, 5, 5, 6, 6, 7, 7. Right? This is how we need to write a Deadlock program for the 8-bit resistor. Okay, which one is simple according to your knowledge? Okay, so if you know the structure of this one, you are able to write a structural modeling like this. If you don't know the structure, we know only the truth table of, or maybe the logic of the function. Then the first one is the simplest one. Okay, so the designer has to reduce his task. Okay, so designer has to reduce his task of writing all the things. Okay, so once we have understand the input output behavior, accordingly we have to write the program for that one. No need to go for the with the complex methodology. Okay, therefore this is the simplest one, simplest method. So for example, in the examination, if they ask write the structure model for the 8-bit register, means obviously we have to write the second one only. Don't write the first one. Okay, fine. Okay, so this is what the register. For example, if we ask you to write a Verilog program for the shift register, for example, 8-bit shift register. Okay, so first one is a left shift operation. The second one is right shift operation. How do we do this one? Of course, the block diagram is as shown. What is the size of the data in? What is the size of the data out? Can anybody tell me? Obviously, there is a clock signal. There is a reset signal. There is no doubt. Okay. What is the size of the DA and D out for 8-bit shift register? Anyone from the class? 8-bit data in or 8-bit data out? Shall we get the same?
1 bit, sir.
No. Okay, it's only single bit only. For 8 clock pulses are required to shift 1 bit to D output side. That means something like this it look like. Okay, so better I have to copy this one only. Then I will explain from this one. Copy. And then paste here. No. ఈ రోజు నా సిస్టమ్ ఎందుకన్నా బాగా స్లోగా ఉందా? I don't know why. copy. Oh, it is copied. Okay, here you can see here. So I want to change this diagram like this. Therefore, I don't want to consider the D7 here. So Q7. Okay, instead what I'm going to do, this will be connected to the next stage, right? Are they agree with me? And here also, we don't want to use additional datas. 8-bit means 8 registers, 8 flip-flops should be there. Okay, but it is a shift register means left shift I'm doing. Okay, from MSB to LSB, the data has to move. The DN of signal will go. So by the way, here I did not mention that this representation previously, but you should remember DN signal, DN signal. Okay, so there should not be any kind of this one also. The additional signals should not be there. Okay, because this data D1, D2, D3 data is coming from previous one only. Okay, so only one data that is coming from here, that is only DAN. Only the data that we are getting here is D out only. Are you agree with me? This is a simple shift register. Okay, so again the same procedure. If I am asking you to write the structural modeling means the data that you know that, but here we have to write the intermediate nodes. So in the previously we did not write the intermediate wise. Okay, the same procedure. So don't forget, if I ask you to write in the structural modeling, the same procedure that we have to use. Only change across the
Input output change చేస్తాం.
Yeah, I'm going to copy this one. Copy. Oh my God, something happened. Where is the change here? The top level module the top level module consisting of only this one only. Okay, this one we can see here. This is the top level module. Okay, so it is similar to that of the D flip flop only. Look like the top level modeling for the D flip flop and shift register is looking like the same. Okay, but thing is that it's different. Okay, so it says shift register, right? Instead of saying like this, I am going to talk about shift register underscore left shift ls for the sake of simplicity. And do I need to write that the input is 7 down to 0? Not necessary. We should not write, not necessary, we should not write. Okay, so that is single bit data only. So output is it a 7-bit, 8-bit? No, it is a single bit size data only. Okay, therefore Q. So then what is happening here? Here if you see intermediate lines are there, right? Intermediate lines are there. For example, this is called, for simplicity, Q7, Q6, Q5, Q4, Q3, Q2, Q0. The last one is D out, right? 6, 5, 4, 3, 2, 1, 1. I need to write 1 here. That is better. Okay, D out. So what is the change here now? First one is same flip-flop only I'm using. So RST clock, what is the first input? DAN. What is the first one? It is DAN. DAN. Next one is Q7. So better I want to write it as Q7 is a vector notation. Okay. Better I want to write as Q7. So this is what I'm writing. Oh, I'm extremely sorry. I'm talking about this one, right? I'm not miss this one kada. దీనికి ఏమవుతుందయా ఇన్పుట్ ఎక్కడి నుంచి వస్తుంది Q1 నుంచి వస్తుంది ఓకేనా ఇన్పుట్ ఈజ్ యాక్చువల్లీ ఇట్ ఈస్ కమింగ్ ఫ్రమ్ Q1 Q of 1 and output is D out. So change చేస్తున్నాను మీకు అర్థమవుతుందా Are you able to understand what I'm writing here? Please respond. Chat box లో రెస్పాన్స్ ఇవ్వండి ఒకసారి
Yes, sir.
ఫాలో అవుతున్నారు కదా ఓకే
Yes, sir.
Next we are talking about the second one. So this is the second one. ఇక్కడ మనకి ఇన్పుట్ ఏంటి మనకి Q2 output to Q1. Okay, so that's what I want to change. This is Q2 is my input, Q0 is my output, sorry Q1 is my output. Something like this I need to change. Okay, change chestara. So better I want to remove this one, otherwise people will think that this is the correct one only. So it is take it as a homework. Okay na? So we have to fill this one, but don't forget to write wire. What is the wire here? Wire is from 7 down to 1, not 0 of Q I am writing. Okay, that is the meaningful one. Wire 7 down to 1 Q, because we are starting from Q now, Q1 to Q7. Okay, that's the reason. Okay, please try to write this one. So is there any simplest method to do this one? That's the question. Yeah, obviously when logical way, that also we can write it here. So let us write now. So don't forget to write the end module here also. Okay, here also end module. So what is the best way that we can write? See here, the logic is here. Behavioral modeling. Okay, so it is based on input output behavior only. Okay, what we can see is that, for example, logic is here is like that logic. So for example, if we have a 8-bit register, something like this. So this is called 1, 2, 3, 4, 5, 6, 7. Okay, let us start here is from Q7, Q6, Q5, Q4, Q3, Q2, Q1, and this is Q0, for example. Okay, so if I say that left shift operation, okay, if I left shift operation, what does it mean? Something like this. 3, 4, 5, 6, 7. Left shift operation means what? So this Q7 will occupying at this place, right? Q7 ekkada occupy avutundi. Q7 is occupying, sorry. Q7 ekkadiki vastundi. Q6 ikkada. Q5 here. Q4, Q3, Q2, Q1, Q0 will remove from that one. But what is the last position? It filled with logic 0, for example. It filled with logic 0. So are you agree with me? So So this is how the shifting operation is performed, right? So the same behavior we are writing with the help of Deadlock program. Okay, it's a simple one notation. Only one statement is more than sufficient. Okay, so first of all, what I have to do is that so I'm going to write my Q output. For example, Q is my output, for example. Okay, Q outputs, for example. If I write like this, concatenation of, okay, 0 comma Q of, what are the positions here actually? 0th position, 1 position, 2nd, 3rd, 4th, 5th, 6th, 7th position. Okay, from 7 down to 1, if I consider, that's more than sufficient. I think the logical thinking. Okay, the first position is filled with logic 0. Okay, first position is filled with logic 0. And from second position onwards to the last, what is the contents that are there? Q7 to Q0 of the Q value will be assigned there. అంతేనా? సో అంటే ఎక్కడి నుంచి వస్తుంది నాకు ఎక్కడి నుంచి ఇక్కడ ఉన్నది ఇక్కడ ట్రాన్స్ఫర్ అవుతుంది. You can see there. So this is how we can logically write the shift left operation. Okay, so this equation that we have to write it in our program for the completeness. So let us write now program. Okay, as everybody knows that what is the top level module? The top level module is something like this. We know that is called Q, sorry, D. This is called Q, for example. Okay, it's a clock signal. There is a reset signal. Now let us write a program. Module left shift operation, left shift 8-bit. So that is having D input, Q output, clock, reset signal. There is no problem how we are writing. First you write the Q, the next output, then reset signal, also possible, but it's not a good way actually. So better don't practice like this. First you have to write reset signal, then write clock signal, then D signal, Q. Earlier it's not wrong, okay, but better you write practice in this method. Okay, so the next one is module, sorry, input. What is the input here now? RST, clock, DN signal. What is the output? Q signal. Fine. Now always at the rate of pause edge of clock, comma, pause edge of reset. So what kind of reset signal that we are talking about? Asynchronous reset signal. Don't forget about this one. If I'm writing the clock with respect clock in addition to the reset signal, it's a reset input. Okay, it is a asynchronous input. Sorry. And finally write end module. So statement if reset is true, if reset is available, RST is available, what is the output? Reset then cost we want to clear the content of the flip-flops, right? So therefore reset is true, then Q is assigned by, see here the Q is only 1-bit size we are talking about, but here we are talking about 8-bit size, right? So better to write a temporary signal. Better to write a temporary signal. Okay, I want to write the temporary signal something like this. Q is only one output signal, right? Okay. So the temporary signal is wire, I am right. Wire, for example, D out. Wire is D out. Okay, so I'm going to write wire here is, what is the wire here? D out I will write. D out is equal to 8D of 0. So all the flip-flops content will be 0. Okay, if the content of the flip-flops are not equal to 0, what will happen? Unknown things will be there. Whenever you are shifting, all the time you will find unknown only. Okay, so that means 8 times that you have to shift, then only the zeros or 8 zeros will come into the picture. But instead of using 8 clock pulse to clear the content of the flip-flops, by using the reset signal, one shot all the flip-flops will go to 0. Okay, fine. Now next, what is the else? If the reset signal is not there, else depending upon the clock signal, the shifting has to perform. Okay, so what is the D out signal then now? So D out is equal to, now I am writing concatenation of 0. So 0 we should not write directly like this. Okay, number notation we should follow. Okay, what is the value in number notation? One bit of 0 I need to write, comma. Okay, what is the D of D out of 7 down to 1? Right? So a small modification that I have done for that one. Okay. Now, what is the Q value now? Okay, every time whenever there is a, whenever the positive edge of the clock is there, this particular statement is executed. That means Q naught will come out of that one, right? So that will be traced for the Q, right? So therefore, just simply for the sake of simplicity, I am going to use for something like this. ఇట్లా రాస్తాం చూడండి ఇక్కడ చాలా జాగ్రత్తగా అర్థం చేసుకోండి. So I'll write here is assignment statement I'm going to use. Assign some Q is equal to, assign Q is equal to D out of 0. So whenever I'll find a D out of 0, that will be assigned to Q, so that I don't want to lose the data of this one. So ఇక్కడ నేను ఏం చేసాను, Q naught అనేది పోతుందని చెప్పాను కదా, ఇక్కడ Q naught will go outside. Okay, but I want to assign to this one to the Q. Okay, so that means the D for the I'm using here is the D as internal signal, and Q will be assigned there. Okay, so therefore this always block and this block will be executed simultaneously. Okay, so assignments, therefore I have done here is a mixed modeling. One is called behavioral modeling for the temporary signal, and one is data flow modeling for the last bit assignment. Okay, so there is a possibility is there. So depending upon your application, that we can use either you can combine the 2 or 3, or otherwise you can use the only one thing. Okay, I hope you have understand this point. So therefore that is the reason why when I'm using the assignment statement for the Q, I did not use the register data type for the this one. Of course it is not possible. Okay, ikkada tappu rasam manam. The D is available inside of the always block, therefore it is better to write in register data type. But what is the size also we have to mention, right? Okay, completely ikkada man tappu rasam. What I have to write here, register reg, what is the size? 7 down to 0 of D out. Now the D out is able to write within the always block, right? So this is how we have to write a Deadlock program for 4-bit, 8-bit left shift operation. But similarly, can you write for the right shift operation? Are you able to write for the right shift operation? Shall we write?
D out 6 down 0, 1 bit
8-bit right shift. So just only the modification here is that I will copy this one for the sake of notes. Copy. So, but please change the name. Okay, what is the name of this module? So don't go for structural modeling. I have written here only for the behavior. Structural modeling and catalog just you can see here. So the opposite. Okay. So the input is something this. Uh, so data move from this side to this side, right? Data is moved from this side to this side for right shift. So data is moving from this side to this side means left shift operation. Okay. So connection also you maintain accordingly. Okay. Next, we have to remove this one. It is a right shift operation, RS. Okay, everything is same, but only the change here is this is not the right one. Okay. So for the sake of simplicity, for understanding, I'm writing this one also. 1, 2, 3, 4, 5, 6, 7. Okay, and the data is actually 1, 2, 3, 4, 5, 6, 7. Okay, so therefore here is actually Q0, Q1, Q2, Q3, Q4, Q5, Q6, Q7. So the Q0 will be occupied at which place? Here. Q0, Q1, Q2, Q3, Q4, Q5, Q6. So Q7 will go outside, but that can be traced by using some anything, by using the D out notation, Q notation. So what is the notation here now? So concatenation of what I have to do. MSP bit positions are starting from Q from 6 down to 1. Sorry, 6 down to 0. 6 down to 0. The last one is 1 bit of 0. That's how we have to do. Okay, so this is acting as this one, right shift register. And the last one is within 2 minutes I'll complete it. 4-bit, for example, not 8-bit, 4-bit universal shift register. Using structural modeling.
Sir, assign Q is equals to D out 7.
Yes. Assign this value is, that's true. This is D7. Thank you. That is D7. Fine. So this is what the universal 4-bit universal shift register, what it has to do. So for example, something like this you do. Okay. So universal shift register, what is the functionality of the universal shift register? Means, so you take the parallel data DAN signal, for example, of 4-bit size and assign it to the Q output as a 4-bit size. Okay, that means it is simply a parallel loading of the data. Okay, so therefore what it has to do? Parallel loading. So parallel loading is the nothing but 8-bit register we have seen, right? Parallel 8-bit register that we have already seen. So this is what the one functionality this shift register has to do. The second one is it has to perform the left shift operation. Left shift operation. So this is also it has to do on whatever the data that is available of once the loading is completed. So that means some data is available in the registers, right? So whatever the data that is available, that must transfer from one end to another end, from right to left. If the data is moving from right to left, that is called left shift operation. Similarly, there is a possibility of right shift operation. That means the data is already present, but what the data must be moved from left to right. So this is called shift right operation. So, but sometimes we don't want to shift any kind of operation. Loading we don't want to do, shifting we don't want to do, only holding the data. Whatever the data is there, that is the storing purpose. That means to store the value, whatever it is there, it must store. That means holding the data. Okay, obviously we know that there is a clock signal is available, there is a reset signal is also available. So these are the global signals that need to be present for every sequential element. Okay, and at a time only one function has to be performed, either the parallel loading, shift right operation, shift left operation, or maybe holding operation. So for that one we need to have a 2-bit selection line. So what we want to do, so the operation is based on the selection line. So if the selection line is equal to 0 0, the selection line is equal, for example, you write here, if the selection line is equal to 0 0, it has to perform. If the selection line is equal to 0 1, left shift operation. If the selection line is equal to 1 0, that has to happen. If the selection line is equal to 1 1, that has to happen. Okay, therefore 2-bit size data is required for that one. Is it clear to all of you? So in addition to this one, so ఇది అంతా మనకు తెలుసు. So in addition to this one, only another 2 points that I want to add here. One point is okay, so one is called MSB shift left operation, LSB. Okay, these points we will discuss later on. So for the timing, I will stop it here. We will see the remaining. This is the next class. I will discuss that point also. Please try to write the Deadlock program for this one. Okay, draw the circuit diagram and write the Deadlock program for it. Okay, we'll see the remaining things in the next class.